Good day, class. Welcome once again to Organic Chemistry. Today, we will be considering the topic structure of carbonyl group. Aldehydes and ketones have a functional group known as the carbonyl group. The carbonyl group consists of carbon and oxygen, and there is a double bond between the carbon and the oxygen, making it an sp2 hybridized. I'm sure you understand what hybridization means because we've already dealt with that in the first year. I believe that is very clear. Okay, now the double bond has large dipole moment due to higher electronegativity of the oxygen compared to carbon. What does that mean? It means now that electrons are not equally shared. Bonding electrons are not equally shared between carbon and oxygen. Of course, oxygen has higher electronegativity compared to carbon. So definitely oxygen is going to pull the electrons towards itself more than carbon. And what does that result to? It means now that carbon now becomes slightly positive, whereas oxygen becomes slightly negative. So the carbon now acts like an electrophile, like a Lewis acid, whereas oxygen acts like a nucleophile, also known as the Lewis base. This polarization of the carbonyl group contributes to the reactivity of ketones and aldehydes. As we make progress, especially when we get to reactions of aldehydes and ketones, you are going to see clearly how the carbonyl group, the functional group, plays a significant role in the reactivity of aldehydes and ketones. Now, many times students make the mistake when you ask them what is the functional group of aldehydes and ketones. They give you structures that are not accurate. The functional group of aldehydes and ketone is carbon bonded to oxygen with a double bond between the two. Now, aldehydes have an alkyl group bonded to carbon and also a hydrogen bonded to carbon. A ketone has two alkyl groups bonded to carbon. This is very important. We should be able to differentiate between an aldehyde and a ketone. You don't want to make mistakes when you start the chemical reactions. Now let us look at common classes of carbonyl compounds. We have the ketones, like we have said, two alkyl groups. We have the aldehydes that have one alkyl group and one hydrogen. You can see the carbonyl group is there. Now we have the carboxylic acids. They also have the carbonyl group and hydroxyl group. We have the acid chloride. We also find the carbonyl group there. We also see esters. We have the carbonyl group there. We also see amides. We also have the carbonyl group there. So it is important that we have an idea of other class of compound besides aldehydes and ketones that have carbonyl group, so that we don't confuse them, especially when it gets to nomenclature and also when it comes to chemical reactions. Please take note of this information. It's very basic, but it's very, very important. Thank you.